Hi, it's me, Muhammad Nur Hakim bin Muhammad Azmi. I'm from Mathematics Elective Unit. In this video, I'm going to present to you about the Task 1 presentation to complete my assignment for MTES3232 Curriculum Studies and Learning Theories in Primary Schools Mathematics. The assignment is Learning Theories and their Application in Teaching Mathematics. First, let me introduce my lecturer, Dr. Rosnah binti Jamba. This is the contents about what I'm going to present to you in this video. First, Introduction to Learning Theories. According to Tenney et al. 2023, learning theories are frameworks that explain how individuals acquire, process, and retain knowledge and skills over time. They help educators understand how people learn and guide the development of teaching methods and instructional strategies. Learning theories focus on the mental, emotional, and environmental factors that influence the learning. Learning theories can divide into two parts. First, cognitive learning theories, and second one is constructivism learning theories. The first one is the cognitive learning theories. What is cognitive learning theories? Cognitive learning theories focus on how people acquire, process, and store information. These theories emphasize the internal mental processes, perception, memory, problem solving, and thinking that will lead into the learning. The key figures in cognitive learning theory are three. They are the Jean Piaget's cognitive learning theory, Jerome Bruner cognitive learning theory, and the David Ausubel cognitive learning theory. How can cognitive learning theory build an understanding of mathematical concept? The first one, active construction of knowledge, which by Jean Piaget. Jean Piaget said that learners build new knowledge by interacting with their environment and integrating new information with existing cognitive structures. In mathematics education, students explore concepts, make mistakes, and adjust their understanding. They're moving from concrete to abstract thinking. Second, discovery learning by Jerome Bruner. Bruner advocates for learning by discovery, where students actively solve problems to uncover mathematical principles. By engaging in hands-on activities, learners develop a deeper conceptual understanding of mathematics through exploration. And last one is meaningful learning by David Ausubel. Ausubel's meaningful learning theory focuses on the importance of linking new information with prior knowledge. In mathematics education, teachers can help students connect new concepts with familiar ones, to making the learning process more meaningful and retention stronger. The second one is constructivism learning theories. Constructivism is a theory that says learners construct knowledge rather than just passively take information. Constructivism is rooted in the idea that the learner constructs knowledge and is often connected with social interactions and contexts. Constructivism emphasizes active, student-centered learning, where knowledge is constructed through experience by student self. The key figures in constructivism learning theory is two. They are Jean Piaget and Lev Vygotsky. How constructivism learning theories build an understanding of mathematical concept? First, connecting prior knowledge by Piaget's constructivism. Piaget said that students build on their prior experiences and knowledge to make sense of new mathematical ideas. For instance, understanding addition can help in learning multiplication as a repeated addition. Second one is the social interaction by Vygotsky's social constructivism theory. Vygotsky emphasized the importance of learning through social interaction. In the mathematics classroom, working in groups, discussing problems, or explaining the solution to the peers will help students refine their thinking and grasp abstract concepts. In any classroom, students come with various backgrounds, abilities, and learning preferences. These individual differences can greatly influence on how they understand and engage with mathematical concepts. By acknowledging and addressing these differences, educators can create a more inclusive and effective learning environment that supports the success of all the students in the classroom. There are 5 aspects of individual differences in the mathematics classroom. The first one is the cognitive abilities. For instance, some students may grasp mathematical operations rapidly, while the other students, they may need more concrete examples or step-by-step instruction to understand the concept. Second one is the learning styles. Some students may prefer visual, and some students may prefer auditory learners. Excel when mathematical problems are explained verbally. And for the kinesthetic learners may require physical movement to fully grasp the concept. The third one is the cultural and linguistic background. The cultural diversity can enrich mathematical discussion by exposing students to varied approaches to problem solving and reasoning, fostering a more inclusive atmosphere. The next element is the motivation and attitude. A student who struggles with self-confidence may avoid challenges, while the one who enjoys with the mathematics education will eagerly take on to the difficult tasks. And the last factor is the socio-economic factors. The students from lower income backgrounds may have less access to extracurricular resources such as the tutoring, advanced calculators, or internet-based tools, which can create gaps in their mathematical knowledge. So, as a teacher can address these differences by providing additional support in class, offering free resources, or creating homework tasks that don't require costly materials so that they can do the tasks at the home. Now, let's discuss about the cognitive learning theories and individual differences based on the 3 different theories. The first one is the Piaget's cognitive learning theory. Piaget proposed that children go through stages of cognitive development: the sensorimotor, pra-operational, concrete operational, and the last stage is the formal operational. In mathematics education, Piaget's theory recognized that learners' understanding of mathematical concepts evolves as they progress through these stages. Younger students in the concrete operational stage need hands-on activities to grasp mathematical concepts, while the older students who are in the formal operational stage, they can handle the abstract reasoning easily. For example, during the concrete operational stage at the range of the 7 until 11, children can perform logical operations with tangible objects like grouping or classifying items, which can help them with basic arithmetic. The second theory is the Bruner's learning theory. Bruner emphasized learning through discovery and categorized it into 3 modes: inactive, learning by doing; iconic, learning through images; and lastly, the symbolic, learning through abstract symbols. This approach can address individual differences in learning preferences by offering multiple representations of the same concept. For example, some students may understand the multiplication topic through manipulatives, which is the inactive mode, while the other students might prefer the diagrams or the iconic mode, and maybe some they need the equation as the symbolic mode to understand the multiplication topic. And the last theory of cognitive is the Ausubel's meaningful learning model. Ausubel proposed that learning occurs when new information is connected to an existing cognitive structure. Individual differences in mathematics education are addressed by connecting new information into what they already know before, on what they have learned before. For example, a student who understands fractions can more easily grasp decimal operations, as both concepts can be connected to the idea of part-whole relationship. Teachers can use advanced organizers, such as maps, to help students relate new mathematical concepts to prior knowledge. Next, let's discuss about the constructivism theories and individual differences based on 2 different theories. The first theory is the Piaget's constructivism learning theory. Piaget's constructivism learning theory focuses on how learners construct their understanding of mathematical concepts based on their experiences. Individual differences are recognized as students construct understanding at their own pace. For example, each student in class construct an understanding of shape properties at their own rate. So the teachers as the facilitator will guide students through problem solving and exploration, allowing them to build knowledge progressively. Next is the Lev-Vygotsky constructivism learning theory. Vygotsky theory, particularly the concept of the zone of proximal development, ZPD, emphasizes the role of social interaction and scaffolding in learning. Students can achieve higher level mathematics skills with guidance from a teacher or peer, tailored to their individual ZPD. In mathematical education, individual differences are addressed through scaffolding, where teachers provide the appropriate level of support based on each student's of ZPD. For example, a student struggling with division topic might be paired with a more advanced friend or receive a targeted instruction from the teacher. The strategies for adapting teaching methods to cater to diverse learning needs in mathematics classroom. There are 4 strategies that the teachers can use to this. The first strategy is the differentiated instruction, tailoring teaching methods to accommodate different learning styles and abilities. Bruner's learning theory advocates for multiple modes of representation. For example, teachers may provide visual representation of concepts like diagram and mind maps. And teachers also can use a concrete manipulative for hands-on learning students like cubes for the multiplication topic. And lastly, the teacher also can offer the symbolic approaches. So there are 3 ways on how teachers can represent their learning for the multiple modes of representation to give to the students with the various learning of style. So it allows students to choose from a range of problem solving methods. The second strategy is the flexible grouping. Grouping students based on their skill level, interests, or learning preferences for specific activities. Cognitive learning theories emphasize the importance of scaffolding, where a more knowledgeable peer or teacher will guide a student to understand a concept that they can grasp independently. They cannot learn by themselves. They need help from others. Constructivism stresses the role of social interaction in learning. For example, teachers can create mixed ability groups for Mathematics.Task, where students of varying skills will be in one group and they will work together, and then they're encouraging the peer teaching. Next, teachers will rotate groups regularly to expose students to different perspectives and interaction opportunities among all their friends. The third strategy is the varied teaching materials. Constructivist theories, particularly those of the Piaget and the Vygotsky, they emphasize the learning through hands-on, real-world experiences. So it means they're using a variety of resources to appeal to different learners. For example, teachers may use visual aids like graphs, charts, and diagrams to support for the visual learner style. And teachers also can incorporate manipulatives like geometry, shape, and block to make abstract concepts tangible for kinesthetic learners. This strategy will allow students to connect abstract mathematical concepts to their real life experience. And the last strategy is the use of technology and digital tools. Leveraging technology to cater to diverse needs and make learning more engaging, more powerful. Technology often promotes discovery learning based on the Bruner's learning theory, which is where students can manipulate variables, experiment, and learn through trial and error simulation in games, which supports knowledge construction. For example, interactive apps and games that adapt to students' level. There are many games that teachers may use now, like Quizzes, Kahoot, and Woodwall. Online platforms that provide instant feedback and personalized learning path. Now, I'm going to present to you one of an example of the lesson plan that applying the differentiated strategies. Topic I choose is the understanding of fractions for the grade level year 4, duration for 60 minutes, and focus for differentiation for diverse learners. So the learning objective, there are 3 learning objectives. First is students can identify, represent, and compare fractions using manipulatives, visual aids, and symbolic representation. Second, students will demonstrate an understanding of equivalent fractions through hands-on activities and digital tools. The last objective is the students will reflect on their learning and connect to real-life fraction scenarios. Among the materials that used in this lesson plan, the first is the fraction manipulatives, such as fraction bars or the fraction strips, that students can physically manipulate to represent the fraction. Second, visual aids, like the chart or a digital display showing visual representation, such as the pizza. The third material is the digital tools, apps or online platforms that provide interactive fraction games and exercises. So this, I choose the quizzes application for the online quiz. And the next materials is the worksheets for the problem sets for practice at different difficulty levels. And the last materials is the whiteboard and markers for teachers to demonstrate and explain the concept using the symbolic representation. Differentiation focus on the three. The first one is the readiness level. There are three levels of the readiness level, which is for the beginner student, intermediate students, and the advanced students. Second is the learning preferences. Some students, they are visual learner, some students, they are auditory learner, and some students, they are the verbal learner. And the third is the support for special needs or high ability learner. The lesson is scaffolding to provide extra support for struggling learners and extend learning for advanced students. The first step on this lesson plan is the introduction, which takes 10 minutes. The activity, teacher will introduce the topic of the fraction using real-life example, such as dividing a pizza into equal parts. Strategy, differentiated instruction using Jerome's Bruner theory, that is the explain fraction in the multiple forms. For the visual learners, teachers will display or show the picture of the pizza that is divided into the parts. And for the concrete, teacher can show manipulatives like fraction circles. And for the symbolic, teachers can write the fractions on the whiteboard using the marker. So some students may prefer the visual or concrete explanation, while the others, they may respond to the symbolic representation. So teachers play important role to check for understanding and adjust explanation as needed as adaptation for the diverse learners in the classroom. The second step in this lesson plan is the exploration activity, which takes 15 minutes. Activity, hands-on activity with manipulatives, fraction circles or bar as example. Students work in pairs to create and compare different fractions using the fraction pieces. This can encourage students to find equivalent fraction by combining pieces. As for example, 2 per 4 is equal to 1 per 2, which is half. Strategy, flexible grouping and varied teaching materials. For the struggling learners, they are placed in a small group together with a teacher for additional support as a facilitator. While for the advanced learner, they are given a more complex task, such as finding multiple equivalent fractions. Materials used is the manipulatives, appeal to kinesthetic learner, and for the visual learner, they can refer to the chart that teachers have already shown in the whiteboard. Adaptation, the scaffolded instruction for students who need more guidance, as a teacher models how to use manipulatives, while the advanced students explore on their own. The third step is the group activity, which takes 15 minutes, and the activity is the group work involving a real-world problem. Students are placed in a mixed ability groups to solve a problem. Maybe teacher can divide students into 6 groups, and each of group have the different ability of students. Maybe some of them advanced learner and the struggling learner in one group, so that they can discuss together about the topic the teacher given. Example, teacher can lead them to share 3 pizza equally among 6 friends. So students need to determine how much pizza each friend gets and represent the solution with the fraction. The strategy used is the flexible grouping with peer learning based on the Vygotsky ZPG theory. Advanced students help explain concepts to struggling peers as they promoting collaboration and understanding, and the teacher circulates, providing guidance and scaffolding where needed. The adaptation, different groups can approach the problem in various ways. For example, struggling students can use manipulatives to understand more easily about the fraction, while the advanced students, they can use symbolic representation to solve the problem. And the fourth step is the digital practice. Takes to 10 minutes. What the activity? The activity is the students engage with a digital tool or application for fraction practice. As this, I use the Canva application. The tool adapts to their skill level, offering feedback and progressively more difficult problems as they improve. For the quizzes application, they can provide the question, and then they can also show the leaderboard on what the points that all students get, and then they can show the ranking of each students, which position are there, and then the quizzes can give students one more chance to answer. If at one time they answer the question wrongly, and then they will give it a one chance so that the students can answer again the same question with the correct answer. The strategy used is the use of technology and digital tools for personalized and learning. Digital games or applications that focus on fraction equivalence, comparison, and representation are used. These tools provide instant feedback, allowing students to correct mistakes in real time. The application adjusts difficulty based on each student's progress. For struggling learners, they will receive simpler fraction problems, while the advanced students are challenged with complex fraction, comparison, or operation. And the last step in this lesson plan is the reflection and conclusion, 10 minutes. Students complete a reflective exercise where they answer questions given by teacher, like, teacher may ask students, what did you learn about fraction today? Or maybe teacher can ask, can you think of another examples where you might use fraction in your life? So the strategy used is the differentiated instruction using reflective exercises for meaningful learning by David Osbel. Students may reflect through writing, drawing, visual representation, or discussing with their friend. Adaptation, for the visual learners, they can create a diagram like charts or the visual that represent the fraction, what they understand about the fraction. For advanced students, they can write or explain verbally about what they understand to their friend in class. So the teacher has encouraged students to use their preferred reflection style. As a conclusion, by incorporating these strategies that contain the cognitive learning theories and the constructivism learning theories, this lesson plan is designed to foster a deeper understanding of fractions while accommodating the varied learning needs of students in the classroom. For the assessment, there are 3 types of assessment that teachers can use. First, for the formative, during the hands-on activity, so the teachers can observe and teachers can assess the students' understanding of mathematical concept. Second is summative, where teachers can assess their understanding by doing the online quiz. And the last one is the performance. Teachers can observe their students' performance in the group discussion. So teachers can observe and teachers can give marks. Teachers can see how they understand and how they can learn by their friend and how they can explain to their friend by discussion. Importance of recognizing individual differences in mathematics education. First, teachers can provide appropriate support for each students with different type of learning style. Second, emphasize tailored instruction based on students' developmental stages and memory capacities. And third one is to encourage active learning and collaboration in classroom by work group and discussion with their friends. Benefits of adapting teaching methods to cater to diverse learning needs. It will allow students to engage with mathematical concepts in ways that suit their individual learning preferences. Second, the use of the technology and digital tools further personalizes the learning experience, offering instant feedback and allowing students to progress at their own pace. And the last benefit is the foster a more engaging, supportive classroom environment. The conclusion, both cognitive learning theories and constructivism acknowledge individual differences in learners, particularly in mathematical education. Cognitive theories highlight the stages of development, prerequisite knowledge, and information processing, while the constructivism theories emphasize the self-constructed knowledge and the importance of social interaction and scaffolding. By understanding these two theories, teachers can tailor their instructional strategies to meet the diverse needs of their students. So this is the references that I refer to complete this task. And that's all from me. I hope you guys understand about what I have presented to you in this video. I hope this video can help you in more understanding of the learning theories in mathematics, especially for the cognitive and constructivism, and can help you to design a lesson plan that suits with the different type of learner of the student in the classroom. That's all from me. Thank you so much.